Hello, we have ourselves a quiz. This is called a fruit quiz or my fruit quiz, and what I'm going to do is I'm going to use different kinds of fruit, to describe a region that you're going to have to integrate over. And so this region is actually a three-dimensional region, so it's going to describe some sort of volume. And you need to find the limits of integration for this. We're going to integrate using rectangular or polar or cylindrical or spherical coordinates. And so what we're going to do is I'm going to, like I said, chop up some fruit, and you get to set up your integral. So let's get started. Well, the first fruit we're not really going to chop up. We're just going to look at an orange or a little tangerine. So problem number one, I'm going to get this tangerine. I'm going to take out just one segment of the tangerine. So this has one little segment. So the tangerine, let's say, has a radius of one unit, whatever that might be. And it's going along the x-axis. And then this is your y-axis. So this is up along the x-axis, and it goes towards the y-axis, the positive y-axis, and the z-axis would go up and down. Okay, so this is your first region. It's a segment of an orange that goes from the top of the z down to the bottom of the z. It's touching the y-axis, or I'm sorry, it's touching the x-axis. It's touching the x-axis going towards, and it's out of 10 segments. This is one segment out of 10. Okay, so that is your first region. Number two, we're going to take that same orange or same tangerine, and this still has radius 1, but it's only half of it, and this one goes through the negative x-axis. So this is your x, this is your y, negative x-axis. This is your x going towards you, y going towards me, positive x going towards you, negative x going towards me, y going this way. So this is your x and your y, and your z going straight up. Okay, and so that portion is on the negative x-axis. It's the whole hemisphere, or it's a half of a sphere. This is the negative x-axis, this is a positive x-axis. The y-axis is this way, so x is going towards you, y is going this way, and z is going up. Alright, so this is number two. It's a half of a sphere opening or going towards the negative x-axis. Okay? Number three, we're going to take a look at a kiwi and pretend that this is a little paraboloid. So a paraboloid, let's say, that opens up along the z-axis. So this is a z-axis going straight up, that's a paraboloid. And what we want to do is we want to cut out a cone out of that paraboloid. So the paraboloid is z is equal to x squared plus y squared. And then we're going to cut a cone out. Let's see if we can do this. So the cone will have the equation z is equal to the square root of x squared plus y squared. So here's the cone that's cut out of the paraboloid. So that's the cone. We cut that out, and now we're looking at what's left of the paraboloid. Okay? So what's left of the paraboloid? It's the paraboloid. The cone got cut out, going up along the Z. So you would probably be interested in where they intersect, and that should help you find the limits. Problem number 4, we're looking at another paraboloid. This time the paraboloid is upside down paraboloid. So it has the equation z is equal to 1 minus x squared minus y squared. And going along the x and the y axis, we're going to cut out where both the x and the y are negative. So that's essentially in the 4th quadrant. So again, the x would be going towards you, the y would be going this way, and where the x and y are both negative, we got that piece cut out. Okay? So this is an upside down paraboloid. Z is equal to 1 minus x squared minus y squared. And then we cut out that portion of the paraboloid. Okay, number 5, we're going to get to the watermelon now. For the watermelon, we're going to take the top half of it, and let's assume that the watermelon's a spherical watermelon. And let's just take the top half of it for now. So we have a spherical watermelon, and we're going to cut out at an angle of 45 degrees. At an angle of 45 degrees, we're going to cut through the watermelon. Okay, let's say that was done correctly, even if it wasn't. So what we have is this piece of the watermelon. So the watermelon has a radius of 7, and then we use the cone to cut it, and we cut this out, and this is what we have left. All right, so the z goes straight up, and then the x and y touch at the very bottom of this watermelon. All right, this has radius 7, and then a 45-degree angle cut with a cone. Z is equal to the square root of x squared plus y squared. All right, now we have the bottom half of the watermelon here, and we're going to cut this into 8 equal pieces. So 8 pieces. So this is cut in half. Cut in quarters. And one more cut. So that's 8 pieces. So I'm just going to take one of them. Again, this is coming from the bottom half of the watermelon. Let's see, this watermelon, so this is your x-axis going towards you again, your y-axis going that way, and this is the bottom half of the watermelon where the positive y it's going along the positive y-axis and going towards the negative x. So the positive x is going towards you, negative x is going backwards. So this is kind of like the top view would be something like this. Something like this. X is going to the right and y is going straight up. And it's going from the positive y going towards the negative x. So if we're looking at that in quadrants, it's like the second quadrant, but it's below the second quadrant. So technically that would be the sixth quadrant, or sixth octant. Okay? So this is problem number 6. So now we get to the pineapple, and for this we're going to take a look at the pineapple as if it was a spherical object, or cylindrical object, sorry. So this pineapple is cylindrical, and let's say it has a radius of 4, but we're also going to, aside from the radius of 4, we're also going to take out a cylinder of radius 1. Kind of like getting rid of the core of the pineapple. Okay, so the core of the pineapple is gone. Now we're looking at this cylindrical pineapple, and there's a plane. So this is the z-axis going straight up, the x-axis going at you, and the y-axis going this way. And then we're going to cut it with a plane. Z is equal to 3 plus 1/2 x. So this is a z and an x. It's going to cross at 1/2. So it's going to get sliced at an angle like that. So there's a plane that cut this cylinder with an outer cylinder and an inner cylinder taken out. So the outer cylinder has radius 4, the inner cylinder has radius 1. You got cut on top by the plane z. Z is equal to 3 plus x squared. Actually, it should be going this way. 3 plus x squared. So it has a slant that's going up along the y, or along the x. Okay. So that's problem number 7. Number 8, we have the same pineapple, except well, we're going to do the same thing. We're going to cut off a cylinder, radius 1. So we're going to cut the core out of the pineapple again. And then we're going to position this pineapple, this cylinder, so that it's between a couple of planes. And the planes are just going to be horizontal planes. The planes are going to be the horizontal plane, z is equal to 2 and z is equal to -1. But we're also going to only use 1/4 of it. So this is your cylinder, we're only taking 1/4 of it, and 1/4 of it on the positive x and the positive y. So the x is going at you, the y is going this way, and so this is positive x and positive y. But it goes z is equal to -2, so it goes a little bit below, and it goes z is equal to +2, and it goes above 2. Okay? So this is your cylinder, or your 2 cylinders that have been cut, and it's between 2 planes. Okay. For number 9, we're going to look at a cantaloupe. And the cantaloupe is one of those objects that have, that's really, the flesh is between 2 spheres. And let's say for this one, the sphere has radius 1, or I'm sorry, the outer sphere has radius 6 and the inner sphere has radius 4. So we're going to cut this in half first. And then we're going to take the inside out. So we see that the cantaloupe is actually, without the seeds here, it's just a couple of spheres between 2 spheres. And so for problem number 9, we're going to take a look at this cantaloupe, and we're going to slice the cantaloupe. We're going to use the cone again. The cone, z is equal to the square root of x squared plus y squared. So that's your standard cone with a 45-degree angle. And then what we're going to do is we're going to take the thing that came out of the cone. Now, instead of looking at this, we're going to look at what's left over. So what's left over is that we have a sphere radius 6 and a radius 4. That's inside is radius 4, the outside is radius 6. And then we use the cone. Z is equal to the square root of 1 minus x. Z is equal to the square root of x squared plus y squared, that cone. And whatever we have left here that's above the xy plane is going to be your solid. Okay? So that's problem number 9. Oops, problem number 9, it says x squared plus y squared is equal to 1. That's not the cone. The cone should be z is equal to the square root of x squared plus y squared. All right, last problem, number 10. We're looking at this again. This time we're going to slice out a segment of this, kind of like the orange that we sliced out earlier. And let's say this has an angle of 30 degrees. And we're looking at this with the x-axis pointing towards you, the y-axis. So this is a segment 30 degrees from the positive y-axis. So from the positive y-axis. So the z is going straight up and down. Let's put the z-axis here. The z is going straight up and down. This is going from the positive y-axis and it's along the y-axis and the z-axis, and it's not really touching the x-axis. So it's in the first octant and in the fifth octant between the positive x and the positive y, but it's not touching the positive x, it's touching the positive y-axis. Okay, and this has an angle of 30 degrees if we look at it from the top. Okay, so that's the last problem. And I hope you're going to be able to come up with the inequalities for these triple integrals, or triple integrals. And hope you had fun.